then I have some class-related things to talk about. I want to talk about registration, which starts on the 6th, because it might be relevant to some of you. Now, you are in A&P2, and that often means that you are planning on starting a program either here or somewhere else in the fall. If you're starting a program here, you're going through the application process for that. And when you get in, then you'll have an advisor, and there's pretty much a fixed set of classes that you need to take. So registration information will be handled there. But and obviously, if you're not going into a program here and you're going somewhere else, the registration has nothing to do with you because you're not going to be taking classes here. But some of you may still be working on classes and you're planning on finishing up prereqs or whatever and applying for the following year. So you might be applying for other classes. Sometimes I have people who are taking me for A&P2 who had somebody else for A&P1, and they didn't like whoever they had for A&P1 or couldn't get into the class, or they didn't like the teaching style or whatever. They didn't do very well. They wanted to switch to a different professor, and so they come to my class. And hopefully for a person that might have made that change, coming into my class was a great experience, and you regret not having taken A&P1 from me before. And in some situations, people in that like that want to go back and retake A&P1 with me to improve the grade. I certainly have many students that have been in that situation. Not that there's something magical about me, but just that the compatibility of teaching styles and learning styles is an important part of succeeding in a class. And unfortunately, you don't always know that until you're into the semester a little bit. So you're stuck in A&P1 and have to make the change for A&P2, and you wish you'd like to go back and do that. And it happens sometimes. So you might be applying for A&P1, registering for A&P1. Or you might have yet to take, microbiology or something like that, whatever. So I do want to point out a couple of things that are new about the registration process. The first thing, which is kind of happening across the campus and has been for a little while, is that the school is updating all of the course numbering codes for everything on campus. And actually, I think this semester might be the last semester that they're doing it, so I've gotten caught up. And in this semester, we've been updating the science and math code, which means the courses are not referred to by exactly the same codes anymore. This class that you're signed up for right now, when you signed up for it last semester, was BIOL 232, and that's the code for A&P2. What the school's doing is going from a 4-letter code to a 3-letter code. So A&P2 from here on out will be BIO 232, which is not a very big change. However, if you do happen to be somebody that wants to go back and retake A&P1, A&P1 at this point, up to this point, has been BIOL 132. It's now going to be BIO 231, which might sound like we've just reversed the numbers, 132 to 231, but really what it is that now A&P1 and 2 are consecutive numbers. So instead of 132 and 232, it's now 231 and 232. The decision was to make it a 200-level course on purpose because that implies right off the bat that it's a more advanced class and not just anybody can walk in off the street and succeed in it. So if you are going to go back and take A&P1, understand that the code is different. It'll still say up on the page, like up there on the screen, Anatomy and Physiology 1 as the name for the course. It's just the code has changed. So I don't want people to freak out about that. With this change to making it a 200-level course, we've also, as a department, made it so that it has some prerequisites that it didn't have before. When you signed up for A&P1, the prerequisites it had, if you want to even call it, were high school chemistry and biology. the thing about that as a prerequisite is that we really can't enforce it. There's no way for us to look at every individual student and look up their high school transcripts, which may be, from the previous year, they may be from the previous decade. I don't think anybody from the previous century necessarily would be, but it's possible. I mean, somebody that was in high school in the 80s might decide to, change careers and they're coming back to school, or something like that. And so we can't go through all of those transcripts that we have on file somewhere. So really in the past, A&P 1 was kind of an open enrollment course, and anybody could walk in. And as department, we wanted to change that. So we've spent the past couple of years actually researching it and seeing what data there is saying what translates to success in the class. And basically, now the prerequisites for A&P are being at college level English and math. So some people that start here after taking the placement tests have to take reading or writing or algebra or arithmetic. So any of those people can't go into A&P 1 right away. What we see is there's people that are at the college level in those basic classes are going to succeed in A&P better. Additionally, alternatively, there's a prerequisite of Biology 101, which is our introductory biology course. It's not required if you meet those college level reading, writing, and math courses. I think that'll suffice, and you don't have to have the intro bio. But if you have the intro bio, I suppose that might supersede the college level English and math. But I don't think it's really likely that anybody's going to be able to. I only mention this because I doubt it would be an actual issue. But if you go back to take A&P 1 now and you never got to college level math, you won't be able to start A&P 1 again. I doubt there's anybody in that situation because probably if you're taking A&P and you're trying to get into the nursing program or something like that, there are other courses that you have to take that have those math type requirements anyways. So you probably are at that level anyways because the prerequisites are already in the system. But just be aware that that's new. And really for students in A&P 1, that's something that we tend to think about. But if you're in A&P 2, you're probably obviously fine with A&P 1, so going back and taking it isn't likely to be an issue. It's built into the system now with those prerequisites. So if you are in the small minority of people that might be going back to take A&P 1, that is the case. That also applies to microbiology if any of you have yet to take that. So just be aware of that. Another difference, which is about sciences in general, is that we're changing an aspect of how courses are listed, not in the code, but rather when you signed up for this class, you just signed up for Biology 232, and it included the lab section. What's going to happen in the future is that you'll have to sign up for the lecture and the lab together as sort of like separate classes, but they're co-requisites. So not that you can read exactly what's on the screen here, but over on the side, under the comments, it says must register for BIO 232 DO1 or whatever it is. So whatever this is the section code for the lecture, and then there's a lab code which just has an L after the number. So Bio 231 is A&P 1 lecture, Bio 231 L is A&P 1 lab, and you have to sign up for those separately. On top of that, you have to sign up for particular sections of it. So if you're signing up for the DO1 section of the lecture, you have to sign up for the DO1 or DO2 lecture lab to go with that. That's confusing for you, and it doesn't really apply to you. Don't worry about it, but it's. I just want to be sure people are aware of it. It's supposed to be built into the system to make sure that you do that and you don't accidentally register incorrectly. But until I see it happen after the 6th, I'm not going to believe it's going to work. So, because the system usually screws up on the first try. Anyway, so I wanted people to be aware of that. It may or may not be an issue for you, but if you do have to take some classes, be aware that there are some changes there. Also, I wanted to mention if you are going to be retaking A&P 1 or something like that, since this is the spring semester, you can take it in summer or in the fall. And I have options for that, and there are other options through other instructors for that too. Over the summer, I teach a 10-week long class, which is very much like this. We meet once a week, and it's 10 weeks instead of 14 like we have here. And then in the fall, I teach a regular lecture lab version of AMP1, and then 1, 2, 3 of this style once a week meeting hybrid classes. I also teach 3 hybrid AMP2s in the spring. So there are lots of opportunities if you need them, if you're going to register for those sorts of things. I just want to make those general announcements, which might not apply to any of you, but in case it does, I want you to be aware of what's going on. So, another thing I want to point out, since it's been a while since we had class coming in today, I just wanted to double check that I knew what we were doing today. And fortunately, I was correct. We're doing the lymphatic system, which we'll get to in a little bit. And this week we're doing the lymphatic system, and next week we're doing the immune system, which are a single chapter in the book. And it's really, the reason I spread it across 2 weeks is that we need more than just one day to deal with this stuff. So I want to spread it out a little bit. So it is 2 weeks in the course. While I was checking that stuff, I always also made sure that the current week and next week pointers were going to the right things, and they are in fact doing that now. So current week points to this week 8 lymphatic system. When I went to set up the next week pointer, I got a little bit of a surprise. Originally, when I was setting up the course, I had it set up with this material being 1 week, and then I decided to change it, make it 2 weeks, which I changed in the schedule that I just showed you, but I didn't change it in the weekly folder format. So this week 8 folder used to say lymphatic and immune systems, and it had 3 learning pods, the lymphatics ones that's here, then the immunity one and the immune system chapter 1, and then this thing, and then 4 assignments about lymphatics, and then 4 assignments about immunity. But not everything was due at the same time. So apparently somewhere along the line, I started to separate it into 2 weeks, but I didn't complete it. So I, in fact, completed that. Now, if you go into the weekly material section, you'll see week 8 and week 9 is now lymphatic and immunity. So next week's folder is the immunity folder. And this is where those other 2 learning pods are. And then the part 1, 2, 3, and 4 assignments about immunity, which are still about the same chapter, but just separated into those 2 topics there. So if you pay attention to the weekly folder page that I was just showing you, it is a little different, but it reflects how the class is actually running and what the schedule says, and is just a better representation. Yeah.
So is the reading for the chapter split up, or are we still reading?
I don't really get too bogged down with what the reading assignments are, because the way I put it in there is just a link to the beginning of the chapter.
Yeah.
What we'll be concentrating on today, really, I'll show you on the book page, the web page, that we're really just paying attention to the first part of it. And then we'll continue on from what we finish today next week. So yeah, it is kind of just the first section of the textbook for a day, and then next week is the rest of the text. Okay. And the learning pods reflect that. The lymphatic learning pod that was due today was really just about that first part of the chapter. And then the immunity learning pod and the chapter learning pod obviously are just the chapter. So it looks like you're about to say I already did that. So if you did those learning pods, you've probably already kind of booked the whole chapter. But technically, we're doing just the first part of the chapter today.
Okay.
No big deal. Which brings me to learning pods. Oh, sorry, question.
I was going to ask about learning pod. I got an email saying that they're going to shut down on April 31st.
March 30th,
March 31st.
which is next Tuesday.
Yes.
I've already talked about this in class, haven't I? Okay. Well, you don't know because you weren't here. That's one of the things I'll pretend. So I already said this, but the fact that you weren't here to hear what I said is okay because I've changed it. So everybody's going to hear a new thing about the Learning Pod. When I discussed this with you before, what I said I was going to do was keep the idea of these Learning Pod type of assignments, but no longer use the Learning Pod website because it's not going to be there after next Tuesday. And what I was going to do is build the same kind of assignment in Blackboard, and you just do it there. Now, the assignment requires that you get scored just upon completing. You get 2 points for doing it on time, 1 point for doing it late. Unfortunately, I can't do that in Blackboard. Every assignment in Blackboard that's going to be graded is graded solely based on the performance on that assignment, so how you do those questions. So I tried building it and making all of the questions worth 0 points, but when I do that, the assignment is also therefore worth 0 points. And I can't say, no, make it worth 2 points. It just doesn't let me do that. It used to, but it doesn't let me do that anymore. And so I started considering other ways to do this. I looked online for some reference. I talked to the guy here on campus that's in charge of Blackboard. And it's just not possible to do it that way. I'd have to do some sort of weird scoring regime, and then there'd be a lot of manual input on my part. So I decided to just scrap the whole idea. Okay. What that means is from this point forward, there are no longer Learning Pod assignments. Okay. I'm sure you're heartbroken over this, but it's just not possible. Because of that change, I'm also making a change about extra credit. Okay, so oh shoot, a little too big. So the extra credit policy I revamped. Now, I don't normally talk about extra credit because part of earning extra credit is for you to put the work into finding out how to earn extra credit. But because of what's changed here, I really do need to state this explicitly. The extra credit previously was basically for you to make learning pods. Okay? And you'd get a point for every good question that you wrote for the learning pods. And the intent was for, therefore, more learning pods to be created, to be out there for practice for future students. But since learning pods are closing down, that's not really worth it. I had thought if I was going to switch from the Learning Pod website version of the assignments to doing them directly in Blackboard, that I just make the extra credit be write some questions for an assignment kind of thing. But since I'm not doing that either, I'm not going to do that with the extra credit. So I'm changing the extra credit. Now what the extra credit is you can finish out the learning pods for the semester. Okay. And so the lymphatic one was due today, well, midnight last night. The immunity one and the immunity chapter, immune system chapter one, would have been due before next week. And then the respiratory system, digestive system, I'm trying to do this in order, or urinary system and reproductive system ones, finish out the rest of the semester. Okay. So now all of those are no longer going to be as graded assignments for the class. So what you can do for extra credit is go ahead and finish those. Okay. And the reason I'm making that extra credit is because you have to finish them soon. The Learning Pod website is closing down next Tuesday. Okay. So if you want to earn extra credit from doing these learning pods, you have to do that over the weekend. I need to get the email from Learning Pod saying that you've completed the learning pod in enough time for me to enter the grades in before the website closes down. If I say you have until the 31st to do it, and I'm going to sit down on the 1st to give everybody credit, I have no idea if when the Learning Pod website shuts down, if those emails are going to suddenly lose all the data that they have. So you have to complete it in enough time that I can sit down and score people for them. So I'm going to sit down Monday morning next week and just go through any of the learning pods I have in my folder and give people that credit. Okay. And once I put that in manually into Blackboard, those points are there. Then after I've done all that, I'll add up those points for everything that, for all the future learning pod assignments, and that'll be your extra credit. Okay. And then I'll delete those learning pod assignments in Blackboard, and they'll be gone forever. I may be able to give credit for things that are done later, but I'm only promising the credit's going to be given for anything that's done by Monday morning. Now, due dates in this class have been, midnight the day before class. That's not what I'm doing, because midnight the day before your next class is too late. Okay? So what I'm saying is Monday morning at March 30th, I'm going to sit down and do this. I'm probably going to start it around 8 o'clock in the morning. So anything that's in my inbox at 8 o'clock in the morning is definitely going to be dealt with. If you do something later than that, if you do it at 9 o'clock that morning, it's going to show up in my inbox while I'm still doing this, because it's definitely going to take me more than an hour to put all those scores in. So things that are coming in Monday morning will get deleted. If something comes in later on Monday after I've sat down to do this, after I've finished doing this, or if it comes in on Tuesday, I might be able to give you credit for those too, but I can't make any promises. So if you want to be sure that you get the credit for them, they have to be in by Monday morning. Okay? And use 8 a.m. as a target deadline, because that's when I'm going to start the process. But there might be a little bit of flexibility. If I have an advisee that schedules to meet with me at 8:30, I'm not going to start. I'm not going to get to do this that much in the morning. Anyways, so that's the plan. That's extra credit. I am rescinding the former extra credit assignment. So any of you that have done extra credit previously, those points are going away. And now if you want extra credit points, you do these learning pods.
So we're gonna take the points that
Any points that you've already earned for extra credit this semester are going to be gone, and you now are going to earn them doing this. I'm sorry, it's because of the change in Learning Pod website. I really wish they'd thought to do this in sync with an academic calendar, and they didn't. So it has to be this way. But you will, while you won't get points for that work, you do get the warm feeling inside for having done some work and learning more about it. Yeah.
Wait, what? You won't get points for the extra credit you've done, like making
If
them
you've
learn?
already done Learning Pod extra credits as the previous one was there, that's no longer accounted for extra credit. It's just doing the my different classes have sort of different implications here because of exactly when their class meets and how many learning pods they have left to do for the semester. So I'm not going to make it restricted to 15 extra credit points like I have in the past. So let's see, if you do the 2 more for the immune system chapter, the 3 for the respiratory system chapter, the 4 for the digestive system chapter, we're up to 13 with the, so there's 15 more learning pods for you. Okay? So you can actually get 30 extra credit points for completing those, which is more than I would normally do, but that's partly because I have to make such a drastic change to the extra credit assignment. And for some of my other classes, they might only have, like 25 points worth of assignments left to go. It just happens to be with when your particular class falls into the schedule. So, also though, implied in this is that learning pods that were due before today, not just the lymphatic one that's specifically for today, but any learning pods from early in the semester need to be completed also. Okay. Now, those are not extra credit. Those are assignments. And if you haven't completed them, then you need to. Because after the 31st, I will not be able to verify that you did those assignments on time. So look through your My Grade section, and for each of the learning pod assignments, it should have a score there. Hopefully it's a 2 because you did it on time, or maybe it's a 1 because you did it late. If there's no score for a learning pod, if it has a dash, that means that you haven't done it or I haven't gotten the email for it. I can't remember now if it was Monday or Tuesday morning, but one of those 2 mornings this week, I got completely caught up on all the learning pods that came on over spring break. So if you've done any learning pods in the past couple of days, I probably haven't input those grades yet. But any learning pods that you believe you did before then and thought that I should have gotten, there's not a score for it. I did not get an email. So go back and look over, and if there are any learning pods that you're sure that you did on time but didn't get scored, resend me the summary results. Okay, so if you did it on time, you go into the learning pod and you click on review, and then you click on email summary. It'll send me the summary that tells me when you actually did it. So if it was on time, you'll get the 2 points. I'm not going to grade it as late because I'm only getting the email now. I'll grade it based on when learning pod says you actually did the assignment. So just go back in there and do that. I don't have a big problem with getting redundancy in this. I'd love it if you didn't send me email summaries for things that I have scored. You don't just send me email summaries for all of your learning pods. Please look at what's been scored, and if it's been scored, it's fine. But if it hasn't been scored, please send me the summary results again so I know that it gets in there. If you don't do that by the time learning pod closes, you won't be able to do that in the future. So any email summaries that I don't get for learning pods that you should have completed by this point in the semester already, if I don't hear from you by this weekend, then you'll end up getting zeros for those because I have no evidence that you did those assignments. Okay, so look through, and if there are any learning pods that you did, but you don't have a score for, just resend the summary results, and I'll know that I'll get that and I can verify it. I don't mind if you do that and then you also check with me by text, or, well, we won't see each other again in time, but if you want to check with me just for verification. I will not automatically verify that I received anything. But if you send something and then you send me another email or a text and you say, I just sent my learning pods, could you just verify that they're there, I'll get back and let you know that they're there, but I won't do that automatically if you're a little worried about that. Because of learning pod closing down, you have to make sure that you're up to date on all the learning pods that have been due up to this point, and then you can go ahead and do any of the other learning pods to earn extra credit. You do not have to do the extra credit learning pod assignments if you don't want to. It's extra credit, it's optional. But there is that chance. Now, I will pay a little bit of attention to the learning pods that you send me for extra credit. You'll get 2 points if you complete them, and I'm not paying attention to how you do on the learning pod. But I will pay attention to things that seem to be done without, sort of like the proper intentions. For example, not because of this, actually before I started announcing this to my classes, I got a learning pod from a student, and the summary page for each question has a smiley face for the ones you get right and the frowny face for the ones you get wrong. There were no faces on this, which means he did not answer any of the questions, but he sent me a summary, okay, of an uncompleted.
How did you get a summary?
What probably happened is
You like enter all the way through.
Yeah, if you don't hit, I think it's submit answer or something like that for each one, but you just click at the number at the top to go to the next question. It doesn't save your answer. And then you hit end practice, and it takes you to the summary page, but you have no answers there. But you can still send that summary of an absence of answers. Probably what happened. So for that person, because it was obvious that they didn't actually do the assignment or didn't do it properly, I didn't get the data, they got a 0 on it. So I will be paying attention to that, and I'm also going to kind of pay attention to, that you've made a real effort at it. If you're just going to go through there and hit A for everything, then you're not going to get credit for it. So that's the extra credit assignment. Any questions about what I'm talking about here? Nope. Okay. So, all right. So let's actually do something today. In the textbook, Unit 4, Fluids and Transportation, is the cardiovascular system, which we've already done, and the lymphatic and immune systems. For the way that they've organized this textbook, that makes perfect sense. The lymphatic system is really part of the circulatory system. But the thing is that really, as in the concept of units within this course, the immune system is a separate unit. It would be very awkward to design the book like that. Except that actually Unit 6 is just the reproductive system. So, but there's 2 chapters on the reproductive system at the end of the book. But it would be a little strange to have a unit with only 1 chapter in it. So they put this chapter in Unit 4 with the cardiovascular system, which actually makes sense because there is a relationship between the cardiovascular system and the lymphatic system. And actually, when I finished talking about blood vessels, which must have been like 3 weeks ago now, I should have ended by showing you this picture here of the capillary exchange stuff. Blood coming into capillaries has a hydrostatic pressure, blood pressure, of about 35 millimeters of mercury. And by the time it leaves the capillaries, the pressures drop to about 18 millimeters of mercury. There's an opposing force at play at the capillaries, which is the osmotic pressure, which is about 25 millimeters of mercury. The difference between 35 and 25 is positive 10 on the arterial end of the capillaries, and the difference between 18 and 25 is a negative 7 on the venous side. And that's what drives filtration of things out of the blood to begin with and reabsorption of things back into the blood afterwards. What's being filtered out are small molecules like nutrients and hormones and those sorts of things, as well as water molecules, because all of this is happening in solution. So water molecules are going to be filtered out, and water molecules and small molecules like wastes and those sorts of things will be reabsorbed on the other side. The thing is that it's not an equal pressure. It's 10 out, but 7 in. So we don't reclaim as much stuff back into the blood after the capillary bed. Left to its own devices, that's going to cause your body to swell up and burst because all this water is going to work its way into the tissue. And if there's nowhere for that fluid to go, then you're just going to keep swelling up and swelling up like the girl in Willy Wonka, you know. But the lymphatic system is actually meant to help with that. Oh, sorry. The main function of the lymphatic system is to drain excess fluid from tissues. So what we're talking about here is, let me go back to this picture real quick. Fluid is coming out of the circulatory system, out of the cardiovascular system, into the surrounding tissue. Okay? And it's not all being recovered. So that excess fluid that's accumulating in the tissues has to be drained some way. And it's drained by the lymphatic system. Now, this picture kind of illustrates it a little bit better. Here we have an arteriole carrying blood into the tissue and a venule carrying it away. In between them, there's a capillary bed. Water will come out of the capillary bed during filtration, and not all of it will come back into the blood during reabsorption. So some of that fluid will accumulate in the tissue. So the lymphatic system originates from small vessels that are sort of integrated in with the blood capillaries called lymph capillaries or lymphatic capillaries. That's what happens here. So as the extracellular space in the tissue starts to accumulate fluid from the blood, the tissue is going to swell. And with that swelling, the cells are going to expand away from each other. I shouldn't say cells are going to expand, but the tissue is going to expand and all the components are going to move away from each other. The extracellular matrix has collagen fibers in it, which are anchored to the wall of the lymphatic capillary. As the tissue swells with fluid, those collagen fibers are going to be pulled upon, and there's going to be some tension which pulls on the cells of lymphatic capillary. When that happens, a little flap opens up in the endothelium of the lymphatic capillary for fluid to move through. The space within the lymphatic capillary has very little fluid in it, and the extracellular space outside has a bunch. And so the fluid will naturally move into the lymphatic capillary, draining the fluid out of the tissue and filling the capillary. That fluid will then move on from the capillary further into the lymphatic system, which these arrows in the middle are suggesting. And there are valves in the system to prevent the fluid from flowing back. So fluid that's accumulating in tissue moves into the lymphatic capillary, and then from the lymphatic capillary, it moves on through the lymphatic system, draining the lymphatic capillary. And then the lymphatic capillary can then accumulate more fluid from the surrounding tissue. And so these black arrows are just demonstrating where that fluid's going. Now, there's a couple of more functions I want to talk about. So let me actually make this functions of the lymphatic system. I want to talk about in a second, but before I get there, I want to talk about these fluids a little bit. So plasma is found inside of a blood vessel. And so that's what I've just drawn here. Okay? The two rows of equal signs represents the endothelium of the blood vessel. Plasma is the fluid inside the blood vessels. Water from the plasma comes out of the blood and into the surrounding tissue. And when it's there, we call that interstitial fluid. Interstitial fluid and plasma are not the same thing. They're both obviously water-based solutions, and they're both going to contain certain small molecules like carbohydrates, amino acids, oxygen, carbon dioxide, waste molecules, hormones, all that sort of thing. All of that's the same between the two. But plasma contains other things that don't leave the blood, okay? Namely the plasma proteins. Plasma proteins like albumin and fibrinogen and the immunoglobulins are too big to pass through the endothelium. So they stay in the plasma. They're not a component of the interstitial fluid. Interstitial fluid is, by composition, not the same as plasma. However, when that interstitial fluid drains out of the tissue into the lymphatic system, we call that lymph, or some sources will call it lymphatic fluid. Okay. Actually, this looks a little strange. I'm putting a parenthesis around attic fluid because sometimes it's just referred to as lymph. These two fluids are actually identical. Interstitial fluid gets into the lymphatic capillaries, and once it's there, we call it lymph or lymphatic fluid. They're the same thing. The only difference is geography. Okay. Now, let's say you live on Route 5. Okay. If you live on Route 5 south of 91, then you're a resident of West Springfield. If you live on Route 5 north of 91, you're representing Holyoke. Okay. So geographically, you're different, but you're still a resident of Route 5. Kind of a weird metaphor, but when I say it's just a matter of geography, it's interstitial fluid when it's in the tissue, and it's lymphatic fluid when it's in the lymph capillary. And in fact, in this picture, they label the fluid within the capillary lymph, and then in parentheses call that interstitial fluid, because it is interstitial fluid. It's just we call it lymph when it's in the capillary itself, when it's in the lymphatic system. I want to introduce another fluid, which is called chyle. And chyle is just lymph plus lipids. Okay. Now, this brings us to the second function of the lymphatic system, which is it transports dietary lipids. Now, yeah.
So stuff that exits chylomicrons.
So chylomicron is describing lipids that are bound to specific carrier proteins, and they travel through the lymphatic system. So yeah, the chylo and chylomicron comes from the same place as the word chyle here. But when we're talking about chyle, it's lymph that's containing lipids. They might not necessarily be in the chylomicron format. They might be attached to different proteins, but same idea, yeah. Now, the transporting of dietary lipids seems like a very specific, and it's obviously a digestive system kind of function, but really it just comes out of the draining excess fluid from tissues. Okay. So this picture I've been showing you all along here, it's just some random tissue. Imagine, however, that this is tissue in the small intestine. Okay, so this is the connective tissue that's in the lining of the small intestine, the mucosal membrane of the small intestine. Let's pretend the mucosal epithelium is just beyond that. Okay, on the apical side of the mucosal epithelium, we have the lumen of the small intestine where we're digesting molecules and we're absorbing them across the epithelium. As those get into the tissue here, lipids move into the lymphatic system with the excess fluid that's draining here. And then carbohydrates and amino acids move into the cardiovascular circulation in the reabsorption aspect of what's going on now. What's different between lipids versus carbohydrates and amino acids?
Structurally contain glycerol till they
No.
they're more energetically.
Stop. Lipids don't necessarily contain glycerol. Triglycerides or some variation of that do.
Well,
Cholesterol is a lipid also. Okay. So lipids as a class, how are they different from carbohydrates?
More ATP, or they're just more energetic.
Has nothing to do with energy.
Basically, you get more energy from lipid than you do carbohydrates.
That's not where we're going with this. It has to do with the reason why lipids go one place and the others go another place. Yeah, it has to do with solubility. Lipids are hydrophobic. They're not water soluble. Okay. You don't want lipids going directly into the plasma because they'll form little oil droplets, what we would call a fat embolus, which will do just as much damage as a blood clot. Okay, it can block circulation and cause a stroke in the brain or a heart attack or something like that. So because they're not water soluble, they go into the lymphatic system for transport. Whereas carbohydrates and amino acids are water soluble, so they go right into the blood. As they pass through the lymphatic system, they're going to be processed. They start out as these things called chylomicrons that we mentioned, which we'll talk about with the digestive system. And they eventually get associated with other proteins, which we call lipoproteins, which help them dissolve into the plasma eventually. You've heard of lipoproteins, but probably not recognizing them by that name. There are two very common lipoproteins. There's high-density lipoprotein and there's low-density lipoprotein, which we normally refer to how? Just by their initials, HDL and LDL. What's the more common street names for those?
Good and bad.
Yeah, good cholesterol and bad cholesterol. So those are more about cholesterol as that type of lipid than triglycerides. But that's the kind of idea that they move into the lymphatic system and then they eventually become part of these lipoprotein clusters, HDL or LDL. And which one it is depends on various things going on in your body. And just want to mention that here in terms of this function, transporting dietary lipids, but we'll consider that a bit more as a digestive function when we get to the digestive system. Finally, the third function is also just an extension of the draining excess fluid. Okay, so in the small intestine, as fluid's draining out of that tissue in the lymphatics, the lipids are going to go with it. But the third one, everywhere in your body, because fluids draining the lymphatic system, it provides a chance for what we call immune surveillance. I think that's how you spell it. I might have the E and the I in the wrong order. I can never remember. So surveillance is, watching out for things. Okay? Something that gets a lot of press time today as we think about our government surveilling us with the NSA and that kind of thing. But what it means here is the immune system makes use of the lymphatic system to do its main functions. As fluid is accumulating in tissues, it's going to drain into the lymphatic system. It's going to bring with it whatever happens to be in that tissue. So if it's coming from the respiratory tract, it might include viruses like the influenza virus that is infecting you and causing you to be sick. Okay? Or if it's coming from your digestive tract, it might include bacteria that have been that are foodborne pathogens in your system, like that. It can move through your body easily in the lymphatic system. Or it doesn't have to be something that has gotten into your body. If there's something going wrong in your body because of the movement of fluid through the lymphatic system, those things are going to move through your body that way too. So if you have cancer, for instance, cancer cells will move from the site of where they're growing into the lymphatic system, just with that natural movement of fluid. Unfortunately, cancer will use that as a means to move to other parts of the body in metastasis. But it also provides the immune system a chance to recognize and fight off that disease state. Okay, so that's immune surveillance. That third function is really just an extension of the primary function, which is draining that excess fluid. So a chapter like this in our textbook, which is fairly common for A&P textbooks, puts the lymphatic and immune systems together as if they're the same thing. But they're actually not. The lymphatic system is the final part of circulation. Okay, so we spent time talking about the cardiovascular system and how the blood that's being circulated through the blood vessels by the pumping of the heart. But at the end of that, we learned that some of the water that's in plasma escapes from the blood into the tissue because of that pressure differential I mentioned earlier today. And we have to get that water back into the blood. That completes circulation. And that's what the lymphatic system is for. It's a circulation component. Because it does that, it has this additional digestive function, which isn't terribly crucial right now, but it'll come up when we talk about digestive system. And it also provides a chance for immune function to take place. Immune function takes place outside of the lymphatic system also. So it's a little bit incorrect to put these two together in a chapter because there's more to lymphatics than immune function, and there's more to immunity than the lymphatic system. So they don't really completely overlap, but they're always put together because of that. And in the way that we're presenting this section of today's class is about lymphatics. The second half of today, I'm going to start talking about immunity, and then all of next week is going to be about immunity. Okay. When we're talking about immunity, we will be considering structures within the lymphatic system, but I'm going to talk about that more today. So, okay, so for this picture, actually, I jumped down a little bit. I went past this picture, which is kind of an overview of the whole lymphatic system. I'm not going to zoom in on this picture because we're going to talk about its components a little bit more using other pictures. But this just shows you the various things that make up the lymphatic system. As red and blue are sort of the go-to colors to describe arteries and veins, and yellow is a go-to color to describe nerves, green is the color that we associate with the lymphatic system. Okay, so when you see an anatomical representation of something and you see red and blue and yellow and green, what you're looking at are arteries, veins, nerves, and lymphatic vessels, which are usually all together. They're going throughout the entire body, so they're usually going to be traveling through the same channels, if you will. Okay. So in this picture, all of these green lines represent the lymphatic system. It's much more extensive than this picture suggests. If this was an exhaustive picture of the lymphatic system, her entire body would be green because it's everywhere. Okay. It has to go to all the tissues in your body. But it's also pointing out some other structures that are part of the lymphatic system. In the head, these two labels here, the bottom one says tonsil, and then the top one actually says adenoid, which we're not going to talk about the adenoids, but they're sort of kind of like tonsils. So when we talk about tonsils, we'll be addressing adenoids with that. And then this is the thymus, which is a gland which sits right here, anterior and superior to your heart. We don't see that in these torso models. They're never present in torso models like this because they block our ability to see the heart and the aorta and that sort of thing. And also, in an adult human, which is what this torso model represents, the thymus is no longer active. It's only active during development. So it's not in the model there because it gets in the way of what we really want to see, and it's not really active in somebody that model is supposed to represent. But it's a lymphatic structure, and more importantly, it's integral to the development of immune function. So we'll talk about that with immune function quite a bit. The spleen is also part of the lymphatic system. This big thing here, which is pointing to something that's integrated with the lymphatic vessels that are green, this is a lymph node, which is sort of the primary type, or I should say, the main type of lymphatic organ. They're sort of all over the place. This is part of the small intestine, and it's in this picture because, especially with the dietary lipid things, there's a lot of lymphatic tissue associated with the digestive tract, and especially the intestines there. And then here we have the femur representing a bone, and the bone is there because inside the bone is bone marrow. There's two types of bone marrow, red bone marrow and yellow bone marrow. Yellow bone marrow is adipose tissue, okay. So it's just fatty tissue. But red bone marrow is a part of the lymphatic system also. Okay. And yellow bone marrow is actually just red bone marrow that's no longer active and it's become fatty tissue. So we don't really talk about the yellow bone marrow. When we talk about bone marrow, we're really only talking about red bone marrow. And we already talked about that with the blood because red bone marrow is where the cells of blood are made, which are red blood cells, hence it's red bone marrow. But also the white blood cells, which are the cells that are primarily responsible for immune function. So there's a tie there between the blood, the cardiovascular system, lymphatic system, and immune function. So that's kind of an overview. This picture, which I've already shown you because I wanted to sort of start off with this, shows the relationship of lymphatic capillaries with blood capillaries and how we drain the fluid out. And then as the fluid moves through the system from those capillaries, they move into larger and larger vessels, which we just call collectively lymphatic vessels. And then they eventually are going to carry that fluid back into cardiovascular circulation. They drain the fluid into the subclavian veins. So these two little insets here show us the right subclavian vein and left subclavian vein, which are colored blue because that's our convention for anatomical representation of veins, at least in the systemic circulation. And connected to that are all of these green things, which are lymphatic vessels draining the fluid in there. Okay. Now, if you look at these two pictures, what we see on the right side is not as much as what we see on the left side. Okay. Really, the big difference is on the left side, there's this big lymphatic vessel, which we call a duct, namely the thoracic duct on the left side. And there's no comparable representation of something like that on, am I doing that right? This is the left side and this is the right side. I might have gotten left and right backwards there for a second. But, so the thoracic duct is on the left side and drains in here. And there's no comparable large duct on the right side. Now, in this picture of the body, we see the purple for the right head, neck, shoulder, arm, and thorax. And then yellow for the left head, neck, shoulder, arm, thorax, and all of the lower body, all of the abdomen and both legs. Okay. Where this division is, where we start to see the right side being separate from the left side, corresponds to a structure called the cisterna chyli. Okay. This is an enlarged space within the lymphatic circulation, which is why it's called a cisterna. Cistern means sort of a big storage space. And then chyli is referring to the fact that it's going to have a lot of chyle in it. Now, where it is where lymph fluid drains from the digestive tract into the duct that's eventually going to go to the left subclavian vein. From the cisterna chyli down, all lymph fluid from the right and left sides of the body are draining together. There are three little things coming out of the cisterna chyli here, which are not labeled, but probably this thing right here is supposed to represent the intestinal trunk, which means the lymphatic vessel coming from the intestines and the rest of the abdomen. And then these two here, which again are not labeled, probably represent the right and left lumbar trunks. They're called lumbar trunks because they're in the lumbar region of the body, but what they are trunks that all of the lymphatic vessels from the lower body, meaning the legs, drain through. The right lumbar trunk is going to be draining right leg lymphatic fluid, and the left lumbar trunk is going to be draining left leg lymphatic fluid. So all of that's going to come together in the cisterna chyli, and so the chyle, the lipid-rich lymph from the intestines, and the plain old lymph coming from the lower body all mixes together, and it goes up through the thoracic duct to the left subclavian vein. Okay. So there's this asymmetry in what's draining where. For the right side, it's just the head, neck, shoulder, arm, and thorax. For the left side, it's the head, neck, shoulder, thorax, and arm on the left side, and then all of the lower body from that point down. Just what the color represents is different. I don't know that there's necessarily any real cosmic reason for this. It really is just because we can't separate out half the intestines from the other half of the intestines. All the intestines have to drain together, so it has to be from that point down, both sides of the body. But from that point up, we do have a separation between right and left sides there. Okay. So, which just shows you that the thoracic duct coming off the cisterna chyli goes to the left side. That's just what it means. Some of that asymmetry probably comes from the same thing that causes the heart to grow on the left side, but I'm not sure. It makes sense if they're related, but I don't know if that's true. So that represents the flow here. Now, what moves the fluid through the lymphatic system is a passive process. It's not possible, or there's not a pump that drives this, like the heart pumps blood through the cardiovascular system. Instead, all of this has to be passive in its movement. And one way that happens is that the lymph nodes, which are these little organs that are throughout the system, are highly concentrated around where there are major joints. So there are inguinal lymph nodes that are around the hip joint, There are axillary lymph nodes that are around the shoulder joint. There are cervical lymph nodes that are around the head and neck area. And there's probably some around the elbow and the wrists, et cetera, But those three that I named are the ones that are most commonly referred to. So as you're moving your body, that as a tissue moves, as you move your hip joints to walk, you're going to be squeezing the lymph nodes, and that'll help to push the blood along. There are valves throughout the system so that the lymph can only move in one direction, and that'll help push everything back towards the subclavian veins. It's a very passive process. There's no specific energy for that. It's just taking advantage of the energy you're expending to move your body. If you don't move your body, then lymph will not move through the system very well. Okay? People who are bedridden have a problem draining fluid from various parts of the body because that passive pumping of the body is absent. Yeah.
And what exactly differentiates a node from the rest of the lymphatic system? Again, I mean, it's just functionally or just anatomically.
It's an organ, so it has a very specific structure and function to it, which is a great segue into what I want to talk about next. Thank you. Which is the various organs. So, I'll come back to this in a sec. And I'm going to skip down a little bit because we can go right to lymph nodes here. I like starting with lymph nodes because they're sort of the main type of lymphatic organ, okay, or lymphoid organ. So you were saying what differentiates it from the rest of the system, and all that we've talked about in the system so far are the vessels. And vessels are just tubes, like blood vessels. The lymph node is an organ. It's a solid piece of tissue. Okay? So we see several lymphatic vessels attached to this. Those vessels are classified in two ways. There are afferent vessels, which are the three here that are labeled, but also for this drawing, this one off to the side and this one off to the side are also afferent vessels. The word afferent just means carrying towards. So these are the vessels that lymph flows through to go into the lymph node. And then leaving the lymph node, these two right here, sort of in this pocket, are called efferent lymphatic vessels. Efferent means traveling away from. So these are the vessels that carry lymph out of the lymph node onto the next, further through the system. There are more afferent vessels than efferent vessels connected to any lymph node. And that's also going to help with pressure in the system. Okay, so think about when we're talking about blood vessels, a large diameter blood vessel is going to have low pressure, low resistance, allowing for better blood flow. And then as we constrict the blood vessel, resistance increases, but pressure increases also. And that's going to increase blood flow. Sort of, that's how I describe it. Instead of talking about the diameter of these vessels, we just think about the collective cross-sectional area of these 5 vessels versus these 2, then there's going to be lower pressure going into the lymph node than coming out. And so as lymph leaves the lymph node, it's going to be at higher pressure than when it came into it, and just helps sort of pump things along the system every time. Okay. And there are valves to be sure that anything coming in through an afferent vessel can't get back out, and anything leaving through an efferent vessel can't get back in. So valves ensure that the movement's all in one direction. Now, when we look at the substance that makes up the lymph node main part, the tissue in there is reticular connective tissue, which is sort of the main type of tissue we see in lymphatic organs. A hallmark of reticular tissue is that there's variation of cell density across the tissue. So the darker staining parts here, like what's labeled as the cortex, have higher cell density in the tissue. And then lighter staining areas might have lower cell density. Now I say might have lower cell density because of where I'm pointing it on the picture. This might have a high density of cells, but they're just staining differently, so they're looking light right there. But at the edge of the lymph node, in this area called the subcapsular sinus, that's definitely a low cell density area. There's very little cells right in there. Since there aren't cells, that means there's a lot of extracellular space for fluid to move through. And so the fluid coming in from the afferent vessels primarily moves through those sinus spaces right at the edge in the subcapsular sinus, and then it'll continue down into the trabeculae towards the middle of the lymph node to make it to the efferent vessels. Okay. In the drawing, you can see a cell dense area a little bit better represented. And in that cell dense area, which is in the cortex, there's actually different regions that stain differently because of the types of cells that are in there. The common cell in there is just referred to as a reticulocyte, which is not a reticulocyte like in making a red blood cell, but it's just a general name for a cell in reticular tissue. In the center of these little lobules of the lymph node, what are called germinal centers, there's a higher density of white blood cells there. So they appear different, they stain a different way, and we can see that. Okay. This appearance of the tissue and lymph node is sort of the go-to example of what lymphatic tissue looks like, lymphoid tissue looks like. Okay. And so I like starting off with this because it's a good example, and for everything else, we can kind of compare it to that. Okay. So I hope that kind of answers your question, Logan, of what's special about lymph nodes versus everything else. Okay. So they're primarily where a lot of this happens. Now, as far as the function of these, beyond the ideas I've already given you about how they help pump the blood through the system, the immune function part of what these do, we'll talk about next time.
So just the trabeculae, that's just another accessory small vessel?
It's not a vessel, it's just some cell sparse regions that fluid can flow through a little bit more easily. Okay. Now I jumped down to show you lymph nodes, partly because it fit in right with what Logan was asking, but also because I'd like to start with that as an example of lymphatic organs, because it is the example of a lymphatic organ. But I actually want to go back up here for a second, because the book starts with talking about the primary lymphoid organs. Now, first off, I keep saying lymphatic organ, and the book uses lymphoid. They mean the same thing. It's a slightly different construction of the word, but they're organs of the lymphatic system. Okay. Now, really, I would like this to say primary lymphoid organs and tissues, because we're going to look at two things here, and only one of them is actually an organ. Okay. And those two things, which are the primary lymphoid organs and tissue, are the bone marrow and the thymus. Okay. Bone marrow is not an organ. Bone marrow is a component of the bone, and the bone is the organ. So it's more appropriately called bone marrow lymphatic tissue or lymphoid tissue. Okay. Now these two, bone marrow and thymus, are primary lymphoid organs or tissues. Okay. As opposed to what we're going to see in a second down here, the secondary ones. Okay. These two are primary. Now, for bone marrow, we really mean red bone marrow. And there's a reason why the word red isn't there. And in fact, where bone marrow is bold-faced here, it actually says red bone marrow. They just didn't make the red part bold. And the reason for that works best in what we're talking about is that these two words are important because of the relationship to cells in the system. So I also skipped over this part right here. This picture is the picture from the blood chapter showing the relationship of the hemocytoblast stem cell in red bone marrow to all the different types of blood cells that are made from it. Okay. The stem cells, and we get all of the platelets, the red blood cells, and all of the different types of white blood cells there. This picture was in the blood chapter. The reason it's important here is because I want to now point out that this side of the flow chart, which originates out of the lymphoid stem cell, separate from this side, which originates out of the myeloid stem cell. This is specifically making what we call lymphocytes. And lymphocytes have the same root as lymphatic system for a reason. They're a big part of immune function, and so they're a big component of lymphatic tissues. And there's two main types of lymphocytes. You might not be able to read it in the figure right here, but this is a T lymphocyte and this is a B lymphocyte. You definitely can read down here B cell and T cell. Okay, so a B lymphocyte is a B cell. A T lymphocyte is a T cell. Now, if we go back down here, bone marrow starts with a B. Thymus starts with a T. And that's on purpose, sort of. The T in T cell actually is an abbreviation for the name thymus. The B in B cell is actually not an abbreviation for bone marrow. What it is an abbreviation for an organ that humans don't have. The analogous thing in the human system is bone marrow, but the name actually comes from the original discovery of B cells that was done in a bird model, and birds have an organ that humans don't have. So the B doesn't exactly make sense for us, but the book says bone marrow instead of red bone marrow here to stress that the B in bone marrow kind of corresponds with the B in B cell. And when we get to talk about the lymphocytes and immune reactions, immune function, next time, I'll come back to that and remind you why that's important. But the primary lymphoid organs and tissues are important because of this relationship directly to B cells and T cells. The other lymphoid organs, called secondary lymphoid organs or tissues, are the other types. Okay, they do all the rest of the stuff for the lymphatic system, but they're not specifically linked to B cells and T cells. And we'll understand why that linkage is there later on. But that's why bone marrow and thymus is primary and everything else is secondary. And so we're going to look at lymph nodes. The other structures we can start with the spleen. The spleen is really just a really big lymph node that doesn't have afferent lymphatic vessels going to it, but rather has blood vessels bringing blood in. So just as lymph goes through a lymph node, blood goes through the spleen. And so a lot of the lymphatic functions that lymph nodes play for lymph fluid, the spleen plays for blood. It basically filters blood, helps get rid of debris and pathogens, old red blood cells, whatever might be in the blood, helps filter that out. It's not entirely evident in this picture, but it's made up of very similar tissue to the lymph node that we just looked at. And we can kind of see here a sort of low quality micrograph showing some of that cell dense part with a germinal center in the center. That's kind of redundant, sorry. But more often we refer to the tissue as red pulp and white pulp. And what we call a germinal center elsewhere is usually called white pulp in the spleen. Red pulp is red because of blood. White pulp is white because of white blood cells. That's basically the relationship there. And then lymphoid nodules is basically referring to tonsils and adenoids. But I want to concentrate on tonsils. If we look at this micrograph of the tonsil at the bottom, which might not be very easy to see on the screen here. Actually, let me enlarge a little bit. So hopefully you can make out in here, there are clusters of cell dense areas, very much like in a lymph node. So tissue-wise, a tonsil is very similar in structure to a lymph node. What's different is more about where we find them and why they do their job. Tonsils are found around the nasal and oral cavities where I should go up a little bit. So nasal and oral cavities where they connect to the throat or the pharynx. There's the pharyngeal tonsil, which is where the nasal cavity connects to the pharynx, right there. So that's perfectly positioned to interact with airborne pathogens. And then there's the palatine tonsil in the soft palate and the lingual tonsil in the posterior region of the tongue, which are right by the oral cavity, which are great for what airborne pathogens we might inhale through our mouth, but also foodborne pathogens for things that we ingest. So the tonsils are arranged perfectly to be in position to deal with those sorts of things. And here we see a picture down through the oral cavity, and we see palatine tonsils on either side there. Okay. We don't see the lingual tonsil because it's sort of back behind the tongue. And we don't see the palatine tonsil because the palate is in the way. I mean, we don't see the pharyngeal tonsil because the palate is in the way there. Yeah.
When people get their tonsils removed, is it like specific one?
It's most often the palatine tonsils, these that you see here. So when somebody has really bad infection in their throat, that infection is going to cause those tonsils to enlarge. The pharyngeal tonsil is not likely to be removed ever because it'd be really hard to get in there. The lingual tonsil might be removed, but it takes a little bit more work to get to it because these obviously you can go in with an open mouth and come out. But to get to the lingual tonsil, you have to go down into the throat a little bit.
Do people without their tonsils are like more susceptible to like getting sick then?
Potentially, yes. But it's not that big of a deal. If somebody has their spleen removed, they have to be very conscious of that. They have to get regular vaccines like the flu shot, and they need to be more aggressive with antibiotic treatment because without the spleen, there's a very significant loss in immune function. But when you take out tonsils, there's enough other lymphoid tissue in the area to pick up the slack, usually. Possibly people that have had a tonsillectomy might experience a slight increase in sore throats versus other people, but I don't know if there's any good data to really say that. And I doubt, I've never had my tonsils removed, so I don't know, but I really doubt that there's a common recommendation post-tonsillectomy saying, you have to be aware of that. And most kids getting their tonsils removed don't really care about that, aren't going to listen to that. So, as an adult, you probably don't remember ever being told that if you were. But it's probably not likely. Now, tonsils are kind of like big lymph nodes. They do not have afferent vessels coming in because they're not draining fluid from the surrounding tissue. Instead, the fluid that goes through the tonsils is the fluid that we find in nasal mucus and saliva. Okay. So as nasal mucus drains, as in postnasal drip, and you swallow saliva, those fluids are going to pass over the surface of the tonsils. And tonsils do not have a smooth outer surface. They have these crevices in them called crypts. And as you swallow things, a little bit of what you're swallowing gets down into the crypts. Now, if you have a foodborne or an airborne pathogen that's now dissolved into the nasal mucus or the saliva, that will get into the crypt. Now, if you're a bacterial, foodborne pathogen, and you get into a crypt, it seems like the best real estate you've ever seen. Okay? It's moist, it's warm, it's dark, it's got good schools, great place to raise a family. Okay? The problem is, and you never discover this until after you pay for the house, the problem is the neighbors are hell. Okay? So bacteria set up shop in the crypt, and they start dividing and forming a little bacterial colony there. Some of them will happen to slip across the capsule wall into the surrounding tissue. And who's there but white blood cells to get rid of them. Okay? And the white blood cells will migrate out of the tonsil into the crypt and get rid of the rest of them. And the white blood cells will move from the tonsils on through the lymphatic system to other structures to make sure that there are white blood cells where those things are headed. So if it's an airborne pathogen, it's probably going to get into your respiratory tract. It's a foodborne pathogen, it's probably going to get into your digestive tract. Now, your digestive tract has a great defense mechanism, which is your stomach. Okay? The pH of the stomach is going to get rid of a lot of foodborne pathogens. If you had a sandwich or a burger or something like that for lunch today, you introduced all sorts of foodborne pathogens, not entirely correct, because pathogens, by definition, make you sick. These didn't make you sick. But your hands are covered with bacteria. It's fact of life. When you were holding that burger or whatever that you ate, some of those bacteria got onto the food and you ate it. The thing is that the bacteria that live in your hand are not pathogenic, really. Some of them can be if they get into your body in a different way, but if they get in through your oral cavity, once they make it to the stomach, your stomach will completely digest them and they're destroyed. You don't have to worry about it. Okay. Now, there are foodborne pathogens that can survive the stomach, and when they get to the intestines, they cause all sorts of problems. But generally speaking, there are a lot of organisms that get into the stomach and they're destroyed. And that's going to happen every day just because of the nature of microbial life in and around you. Okay. So those are tonsils. Adenoids are similar to tonsils. It's more lymphatic structures, lymphoid tissue, around mostly the nasal cavity. So there's more than just the palatine, I keep doing that, pharyngeal tonsil for airborne pathogens. There's adenoids up there too. Then the next, and the last part here is what's called mucosa-associated lymphoid tissue, which is abbreviated MALT. And then down below, they have bronchus-associated lymphoid tissue, which is abbreviated BALT. I've never heard of bronchus-associated lymphoid tissue until this book came along. And all they say about it is this little blurb right here. Really all it is it's MALT in the bronchi. Okay. So mucosa-associated lymphoid tissue. You have a respiratory mucus, a digestive mucus, a reproductive mucus, I shouldn't say mucus, mucosa, and a urinary mucosa. In those tissues, in those membranes, there's lymphoid tissue. Okay. It's not an organ unto itself, it's tissue that's incorporated into the digestive tract organ, or the reproductive tract organ, or the respiratory tract organ, or the urinary tract organ. So it's lymphoid tissue, not a lymphoid organ. There's a lot of it in the small intestine, which is actually why the first picture in this chapter had the small intestine represented there, because that was sort of their poster child, so to speak, for MALT. Because of the digestive functional lymphatic system of transporting dietary tissue, dietary lipids, and the necessity of paying attention to possible foodborne pathogens, there's a lot of lymphoid tissue in the small intestines. And that's actually called Peyer's patches. So the more formal name for this is MALT, but in the picture, they're labeling a couple of little clumps of lymphoid tissue in this cross-section of the small intestine, and they're labeling it, calling it Peyer's patches, which is kind of an old-fashioned name for it. Now, this is showing us the small intestine. We're going to see the same thing in the large intestine. This picture could almost be a cross-section of the appendix. The appendix is considered a lymphoid organ because its only real functions have to do with immune surveillance and response. You have bacteria living in your large intestine. And you've worked out this kind of nice arrangement with them that they live there, you give them food, and they do some nice things for you. And there's some evidence nowadays actually that what species of bacteria you have living in your large intestine might have a direct relationship to various health issues like obesity, heart disease, that kind of thing. So this is the appendix right here. It's this little worm-shaped structure hanging off the end of the large intestine. This end of the large intestine is the beginning of large intestine. This is where the small intestine connects to large intestine. And there are bacteria living in large intestine. And we want them there. We don't want them to move from large intestine to the small intestine. So the appendix is right there to help out. There's sort of two schools of thought about exactly what the appendix is for. One is that it acts as a surveillance device, kind of like a lymph node or a tonsil and their locations, for these bacteria that might try to migrate from the large intestine to the small intestine. There's also a school of thought, which I haven't read much on since I saw the original article, that it actually is a haven for the bacteria that live in your large intestine that you want to keep. So you have a sampling of the good bacteria living in your large intestine, and if you get some out of control infection of gut bacteria, those are protected from your immune system fighting off that infection, and they can migrate out and repopulate your large intestine again after you fight off the infection. I don't know which one is necessarily true. I hear more about the first one, which is that it's involved in the immune response to intestinal bacteria getting out of control. But that's just to say I'm not an expert on it. I'm not positive what the actual thing is. So that's the lymphatic system, running through the various organs. The rest of what I want to do today is to introduce the immune response. Next week, we're going to talk more specifically about the immune system aspects, what's specifically going on. What I wanted to do today is to introduce that. So let's take a break, and when we come back, we'll do that. Let's be back in here by 1/4 at the latest. It'd be great if everybody could be in here at 20 till. That'll give me a lot, but plenty of time to do what I want to do. So, and then we'll move on from there. Oh, wait a second. I'm off by an hour. 1/4 till is fine. We'll have plenty of time if everybody's back by 1/4 till.
Were you thinking that again?
Well, I was thinking that was 3:30, not 2:30. I have a little trouble with analog clocks sometimes. So yeah, be back in here by 2:45 and we'll be fine.